In this topic, we are going to learn about arc lengths. Given a line segment AB here that touches the circumference of the circle, the line segment AB is known as a chord. The length AYB here that lies along the circumference is known as the major arc. It is known as the major arc because it is greater than the semicircle. Whereas the length AXB here will be known as the minor arc. The area of a major segment is the area bounded by a chord AB and the major arc. And the minor segment is the area bounded by the chord AB and the minor arc. For a sector, we will have two radius, and the area of the major sector is the area bounded by these two radius and the major arc. Whereas the area of the minor sector will be the area bounded by the two radius and the minor arc. And this is how the sector and the segments look like. A sector looks like a Pac-Man eating a pizza, whereby the Pac-Man is the major sector and the pizza is the minor sector. The perimeter of a circle is also known as the circumference, and the formula is given by 2 pi r. Here we have a semicircle. What do you think is the arc length ABC? Yes, it should be half the circumference. Therefore, we will have the arc length ABC equals to 1 over 2 times 2 pi r. Now, you'll notice that the angle subtended by the arc ABC here is 180 degrees, and 180 degrees out of 360 degrees happens to be 1 over 2. Next, we have the circle divided into 4 quadrants. What do you think is the arc length DEF here? Since it is divided into 4 equal parts, therefore the arc length should be a quarter of the circumference, and we will have 1 over 4 times 2 pi r. You'll notice that the angle subtended by the arc here is 90 degrees, and 90 over 360 happens to be 1 over 4. Next, we divided the circle into 6 equal parts. Now, what is the arc length PQR? Yes, it should be 1 over 6 of the circumference, and we will have 1 over 6 times 2 pi r. Since it is divided into 6 equal parts, the angle subtended by the arc PQR here should be 60. Once again, 60 over 360 happens to be 1 over 6. And the arc length PQR can also be found using 60 out of 360 times 2 pi r. By now, you realize that the angle subtended by the arc is directly proportional to the arc length. Here we have a sector OXYZ. Now, what do you think is the arc length XYZ, given that the angle subtended by the arc is theta? Since the arc length is directly proportional to the angle subtended by the arc, therefore, the arc length XYZ will be equals to theta out of 360 times 2 pi r. And this is the formula for finding the arc length. And r here is the radius OX and OZ. Let's look at an example here. We are asked to find the arc length of sector OABC. Applying the formula, arc length is equals to theta over 360 times 2 pi r. Since theta here is 100 degrees and the radius is 7 centimeter, we will have 100 over 360 times 2 pi 7. And Using the calculator, we will have 12.2 centimeters rounded off to 3 significant figures. In this example here, we asked to find theta given that the total perimeter of the sector is 180 centimeters. Now, the total perimeter of the sector is given by the arc length PQR plus the 2 radius. Since the perimeter is given to be 180, we will have 180 on the left hand side. And theta is unknown, so we will still have theta over 360 here. For 2 pi r, we will have 2 pi 25, and each of the radius is 25 centimeters. To simplify this equation here, we will subtract 50 on both sides. And it will be simplified to 130 equals to theta over 360 times 50 pi. To find theta, we will divide 50 pi on both sides. And this will give us 0.8276 equals to theta over 360. Finally, we will multiply 360 on both sides to give us theta equals to 297.9 degrees rounded off to 1 decimal place. In summary, the circumference of a circle is given to be 2 pi r. And given that the angle subtended by the arc is theta, the formula for the arc length is theta over 360 times 2 pi r. And the theta over 360 here will give us the proportion of the circumference in order to find the arc length. Likewise, for a major sector here, the reflex angle XOZ here will be theta. And once again, theta is the angle subtended by the arc. That's all for this topic.